Hello everyone. In the series of learning data structures, our today's topic is Malloc. So we already discussed in the previous lecture what exactly is dynamic memory allocation and why exactly we need dynamic memory allocation. So in the programming world, every space counts, and it is always better to use only that much space how much we require. And after once you are done with the execution, it's always better to free up the space. So for doing so, for allocating the memory dynamically, we require dynamic memory allocation. Already the difference between static and dynamic memory allocation I have told in the previous video. You can refer those videos if you have not gone through all those videos. Here in this malloc function, what we are going to do, we will be seeing how exactly we allocate the memory dynamically using um, one code in C language. So malloc is a C inbuilt function, or I should say it's a method for allocating the memory dynamically. The another name for this malloc is memory allocation. It's a memory allocation method in C, and it is used to dynamically allocate a single large block of memory with the specific size. So whatever size the user is requesting, that many bytes, or I should say that much bigger block will be allocated. It returns a pointer of type void, which can be cast into a pointer of any form. So after that, after allocating, it will return a pointer which will point to the first byte of the allocated space, or I should say the block of memory what user is requesting. After that much block is allocated, one pointer will be point to that allocated space, the first byte of that allocated space, and it will be a void type pointer. So you can typecast it to any type. Okay, so let's see the syntax for this. Here as you can see, I'm writing the pointer ptr, and this pointer ptr here, this malloc function will give some bytes uh, of size whatever user requests, that much bigger block will come from here. And here this cast type pointer, this is the data type of the pointer that is being created. For example, this ptr. So for example, let us suppose we are dealing with integer place. So here 10 into size of integer. So what will happen here, since the size of integer is 4 bytes, so this statement will allocate 10 into 4, that means 40 bytes of memory dynamically at runtime. Now, this PTR will hold the address of the first byte in the allocated memory. So this is the cast type of this PTR. As we know that if I'm adding two integer, I need another integer variable to hold the value. So here when we are dealing with integer, 40 bytes, bytes, bigger bytes block is allocated of integer type. We need a integer type pointer to point that particular place. That's why the casting type here is integer. Another important point to remember for malloc is malloc initializes each block with garbage value. So when the initialization is done, automatically by default garbage value will be present in that block. So from here, if I'm saying 10, I'm writing this syntax. In that 40 bytes bigger block, there is some garbage value will be present, and the first location, the first uh, byte will be pointed out with this ptr, with a name ptr. So let's write a program for this so you will understand the concept better. Let me create the file. Malloc.c. So first I have to include the header files. So hash include because I'm going to use printf, scanf. So I'm using stdio.h, which is standard input output header file. Another, because I want to do dynamic memory allocation, I have to include one more header file, because malloc, calloc, realloc, and free, all these functions are C inbuilt function, and their definition is present inside standard library header file. So I have to use stdlib.h. Now this is my main function. So void main. Now inside this main function, let's first we have to initialize our variable. Whatever variables we are going to use, all those variables we are going to initialize. So first thing, I'm taking an integer type variable. For that, let us suppose the variable name is num. Another, I'm taking an integer type pointer. As I'm saying, if I'm asking user to allocate the 10 bytes or 40 bytes, some bytes space, only a pointer with the same type can point to that block. So I'm taking a pointer. For example, this is a malloc program, so I'm calling the pointer as mptr. And to print all those values, I will apply loop. So I'm taking a variable I for that. Now, if any other variable I will be requiring, I will add it later. So this pointer will hold the base address of the block which we will create, as malloc creates entire memory block, how much you are requesting. So this mptr will point to the base address of that block. Now, what we have to do next, we have to ask user to enter how many elements user wants for this program. So this all will happen dynamically at the runtime. So printf enter number of elements for the, now it will become an array. If this num is only one value, then it's a variable. If this num is holding more than one value of integer type, then it will become an array. So here we are dealing with, we are creating a dynamic array, right? And I'm using here \n so that it will come to a new line. Now, because user will enter, so I have to read that value. So here it will be scanf. Now, integer type value is coming. So I have to give the format specifier. Format specifier for integer is %d, and I want to store it at address of num, where num is there. I want to store this value there. Now, we have to now dynamically allocate the memory, because we are asking for more than one byte, and right now we have not given anything. Right now this num is only one variable, right? And let us suppose I want four bytes, means I want four blocks. So what I supposed to do, I have to allocate the memory dynamically. For that, what is the syntax? Here if you can see the syntax, ptr cast type means casting type of my uh, pointer variable. So there also I'm using integer, so integer pointer will come. Malloc, here I have to give the how much bytes, how much blocks I need. So here it's writing 10 and the size of integer is 4, so 10 into 40 bytes will be allocated. 40 bytes block, a block with 40 bytes will be allocated to us. Now here similarly we will write, so my pointer name is what, mptr. We will use assignment operator. Now casting type, obviously this num is of integer type, an integer type pointer only can point. So casting type for this mptr is what, integer. So here I'm writing the casting type for this, that is int. Then the keyword malloc. Malloc is a function. As an argument, what we have inside now, user will enter the size dynamically. So how many elements, that value is going inside num. So here I will use num into, and then what I have to give, I have to give size of. So size of operator will give me size of whatever data type I will write here in this bracket. And as you can see, I want size in terms of integer. So 4 bytes and whatever value I will write here, for example 4 or 3, so 3 into 4, so that much size will be, that big block will be allocated to us. Now I'm putting a statement terminator, that is a semicolon. So after this, we have to check whether the memory is allocated or not. So one point to remember, if the memory is allocated, then this MPTR will point to the base address. If this memory is not allocated, this MPTR will point to the null value. So here we can give the condition on the basis of this logic, that if MPTR, now we have to check equality, that's why double equals to null. So if it is null, that means it is not pointing anywhere, that means memory allocation is failed. So I just give a error message here, that no memory allocated. So we will get an error message if memory is not allocated. Now, if the memory is allocated, I will never enter inside this if block. Then what will happen? I will come inside else block. So here I'm creating one else block. So here inside this else block, I will give further things to check for allocation. So here, if memory is allocated, then only I'm coming here. So first thing, I will print a message on the screen that memory allocation is done. Right? So using malloc, memory allocation is done. Now what I should do, if let us suppose four variables, four places I got of 4 bytes, so that means I can put some values there. That means there is a num0, num1, num2, num3 and num4 is there. If this num value I have taken 4, so num0 to num3 is there, sorry, right? So what will happen, if the allocation is done, we can do what, we can assign some value to those places. Here if you can see, I will draw this for you so it will be more clear. Let us suppose the user is entering here 4. So what will happen, 4 into size of integer is what, 4. That means a 16 byte is allocated here. That means 4 bytes for num0. It will be like this, that here I'm having num0, then I will be having num1, num2 and num3. Now what I want to put values on these indexes, right? So here what I can do is I can put a loop, because here there are these many values. So we can do, we can put a loop, and then we can allocate the memory, right? So here let me put a loop. It will start with 0 as it's an array index starts with 0. It should go from 0 to this less than this num, right? So if 4 places are there, then 0 to 3. So I less than this num and I plus plus. Now here what I can do, here I can assign, let us suppose I just assign 1 2 3 4. So how to assign this pointer variable, what is the name of pointer variable, mptr. This pointer variable is pointing to this. So when mptr is 0, When mptr is 0, I want to assign 1 to it. When mptr is 1, I want to assign 2 to it, right? So what will happen here, I will use I value is 0, then it will become 1, then it will become 2. So here I will use mptri. So mptri means at the 0th location, what I want to store, I want to store at the 0th location, for example 1. So here I can give I value is 0. So if I am writing I plus 1, every time it will increase 1 and then it will store, right? So what will happen here, I value is 0, on that location I will get 1, then increment will happen. Obviously it is less than 4, so I value is now 1. So at first location I will insert 1 plus 1, that is 2, and it will go on, right? So this is the for loop for me. Now allocation is done. Next, what we have to do, let's print the value so we can see how the allocation is happening properly or not. So here, let me put one more printf. We are just now displaying the values, right? So printf entered values with memory location. So we will display memory location also, and we will display these values also. Obviously I will need a for loop, so here we go. I will put the for loop because more than one value is there. So when we will put the for loop here, I can print simply printf value, or I should say element, and this element means here I want to fetch an integer value, so percentage d, and it is on stored on which location, that also we can print. So stored at, and here also I will give 1 percentage d, right? So what will happen here, this percentage d will get its value, for example on position 0, or num0 is what, num1 is what, num2 is what, that value we want to fetch here. How to do that? With simple mptr, because pointer is pointing to the base location, to the 0th location. So if I will write mptri, with each increment I value will change and it will print the value for me. Now, second thing, I want what? I want the address. So how to fetch the address? With address operator, we can fetch the address. So for this percentage D, I'm writing the address operator, that is M%, and then I can give mptr. So this will print the value present at 0th location. This will print the address present at 0th location. I value will increment. Then same thing for first value and then first location address, and it will go on. So till the time the loop is not exiting, we will be able to see all the location and the value which we are inserting. So that's it. I have closed this else loop. Here, this is the closing of void main. Let's run the code and we will see whether this program is running properly or not. So gcc malloc.c. If there is no error, it will come to the next line. If there is any error, it will show us. So as you can see, it's coming to the next line. There is no error. So I will simply compile this thing a.exe. Now, it is asking me enter the number of elements for the array. Let us suppose I am entering 3. So what will happen inside num, this 3 is going. Now 3 into, because size of integer is 4. So 3 into 4. So 12 bytes are allocated, and PTR will point to num0. If I will do enter, as you can see here, memory allocation is done. That means we are not entering inside if block. Entered value with memory location element 1 stored at 166504. Now if you can see, integer take 4 bytes, so there is a difference of 4 bytes here: 504, 508 and 5012. So like this, using malloc we can allocate the memory. So this was memory allocation using malloc. I hope this topic is clear. This is it for today's session. Don't forget to share and subscribe. Thank you so much.